data. So the same data could have been given to you in a different form. Okay.
Okay.
The same data could be given to you in this form. Suppose I write this data over here like this. Say 1, 3, 2, 0, 0, 1, 3, etc. and then a 4. Do you understand? I have written the same data in a simple list form.
Yes.
Okay. So when we
Okay.
arrange the data in this form, it tells us how each value is distributed in the entire data set. Okay. So you
Okay.
can, if I write all the values here, then you will see 0 appears 5 times in this entire data. Okay. 1 appears 4 times in this entire data, and so on. All right.
All right.
But this is already given to us in a nice form. So
Oh.
if you have to find the mean, you have to see what is the contribution of 3 in the overall sum.
There's 2 of number 3.
That's right. So 3 appears 2 times. Okay. So
Yeah.
we would say so the contribution of 3 in the entire data would be 3 times 2. Okay.
Yes.
Similarly, if we complete this calculation, we will see 2 appears 4 times. So it is 2 times 4. Then 1 appears 4
1
times, so
times
1
4.
times 4 plus.
0
See,
times
this
5.
is just for the sake of calculations. Okay, 0 times 5, we know it is 0. It won't
Yes.
contribute anything, but it is important to understand that there are 5 values which are 0 because they will be required in the denominator. Okay, so
Okay. Okay.
yeah, so what is the sum of all these values? Okay, what is the sum of all these values? So 5 plus 4 plus 4 plus 2 plus 1. How much is this?
Only 22. 22 divided by.
Yeah, so we have 0 plus 4. 4 plus 8 is 12. 12 plus 6 is 14 plus 1 plus 4, 18, right?
Right.
So we have 18 divided by 5 plus 4, 9 plus 4,
So it should be 11/8.
13. Sorry.
I mean, 18.
Oh,
Plus
yeah, you're
4.
right. That's 22. That's not
Yeah, it
18.
should be 22.
You're right. Thank you. So this is 22 over. What is the total sum in the denominator? 9 plus 4, 13 plus 3, that is 16. Okay,
Yeah.
so x bar is 11 over 8. Okay,
Okay.
so we have just put in the numbers. So in terms of notations, you have to understand what we have done here. Okay, so in terms of
Okay.
notations, these are your x values and these are your corresponding frequencies. This is x1 f1, this is x2 times f2, x3 times f3, and so on. This is x5 times f5, and this is the sum. Okay, so
Okay.
addition in a short form is written as sigma. Correct?
Yeah, I got it.
So this is sum of all numbers of what type? Of the type fi times xi. where I changes, in this case, I changes from 1 to 5,
Oh, okay, I see.
divided by sigma Fi. Okay. Now what is
Okay,
sigma Fi? These are your frequencies F1 plus F2 plus F3 plus F4 and F5. All right.
all right.
So we, in short, we don't have to write this I every single time. This is just a counting mechanism. We don't have to write that every single time. So in general, we write X bar is sigma Fx over sigma F. Okay.
Okay.
Now, this will give us a very important term. And can you make sigma Fx the subject from here? So this will give me sigma Fx is X bar times
22
sigma
time,
F. Correct?
uh 11 over 8 two times the whole frequency, like
Correct. 11 over 8 times the frequency, and the total frequency was 16. Okay.
oh, okay.
Yeah. Hmm. So this is sometimes required, as we will see as our lesson proceeds. Okay. That why
Okay,
this is important. This is the sum of all observations, right? The
right.
sum of all. Are you comfortable with the word observations, or you want me to use items or something else?
And this
Are the
is
word
okay.
observations okay? Yeah. All right.
Yes.
Okay, so this is the sum of all observations, and the right hand side is mean times the total frequency. Okay, very important and very
Okay.
simple, but very important. Yeah. So we have found the X bar is 11 over 8. So either you can leave it as 11 over 8, a fraction, or you can write the answer in three significant figures. Okay.
Okay, okay,
Therefore,
okay.
therefore X bar is 11 over 8. What can you say about the median?
Median just um
What is the meaning of the word median?
like the middle number of
The middle
uh
number,
yeah.
right? But when?
Um in the whole range of data.
Yeah, in the whole range. But when the data is organized
Oh,
in order,
organized.
okay? When the data is organized in
Okay.
order, like either you write it from biggest to smallest, or you write from smallest to biggest, okay?
Okay.
So don't try to find the middle value without organizing the data. But the way data is given to you in this table, okay, I'll just make this table once again, but in the vertical form, okay, in the
Okay.
vertical form. So we have the same data is now, say, these are your X values, and you have corresponding frequencies here. So what are the values? 0 appears 5 times, 1 appears 4 times, 2 appears 4 times, 3 appears twice, and
Oh,
then you have 4 appears once again, right?
yes.
4 appears once. Okay. So here we write total, and here we write, what was the total sum? 16. Okay.
16, yes.
Yeah. So notice here that we have even number of observations. 16 is an even number, correct?
Yes.
So when we have even numbers, say A, B, C, and D, then there are two middle values, correct?
Yes, two middle
So when
values.
there are two middle values, we take the average of them. Suppose these are arranged. these are in order, okay?
Okay.
Arranged in order. That means A is less than B is less than C is less than D. So here in this case, median, that's denoted by MD, is B plus C divided by 2.
Yes.
Okay.
Okay.
So in this case, because we have 16 values, what are the two middle values? This means 8th and 9th
Oh, okay.
values are in the middle. Okay.
Okay.
So to figure that out, we have something called cumulative frequency. Have you heard of the word cumulative?
No.
Okay. So cumulative frequency is CF. Okay. It is also
Okay.
called the running total. Running total. Let me just write this down. You will see what is meant by running total.
Oh,
So what was this data about originally? Well, there's no context given to you. Okay. Let us give
okay.
this a context. Suppose this data is about how many times a student remains absent in a month.
Oh,
Okay. Suppose this
okay.
data is about how many times a student remains absent. Okay. So
Okay.
0 absentees, 5 days. Okay. One
Okay.
absentee, 4 days. Two absentees, 4 days, like that. Okay.
Okay.
So if I ask you a question, how many students were late for 0 days?
Pardon?
Look at this.
How many students are listed?
How many students were late? Or the question could be,
The first. You mean for the first five? There's only a 0.
yeah. So X, let's say X is the number of absent days. Okay.
Okay.
And F is the number of students. Okay. So how many students were late for none of the days?
0.
5 students
Five.
were
Five.
late.
Five. Five. Five.
Okay.
Yes. Five.
5.
Okay.
So now if I ask you, how many students were late for at most or absent for at most one day?
9.
At most one day. That's right. So what you are doing is you're adding 4 with this. Okay.
Yes.
So give you 9. Okay. How many students
Okay.
were absent for at most 2 days? So then you're doing this plus this, and that gives you 13.
13. Yes.
And then you have 15,
15.
and then you have 16.
16.
Okay. So this is the running total. All right.
Hmm.
Or this is the cumulative frequency. Rather, this is called less than cumulative frequency, because I was asking you how many students were late up to a particular number of absent days. Okay,
Oh, okay.
up to something. So less than or equal to. All right,
All right.
less than or equal to. So you see, up to 9 values were 1. You understand what I'm just saying? I'm saying
Yes.
this tells me there are 5 values which are 0. So it is 0, 0, 0, 0, 0. And then there are 4 values which are 9. So it is 4. Sorry, there are 4 values which are 1.
1. Yes.
Correct? So it is 1,
Yeah.
1, 1, 1. And what values are we looking for? we are looking for the 8th and 9th values. Okay.
Yes.
So
Okay.
this is my 8th value. This is my 9th value.
Oh, so median is 1.
So median will be average of these two. That is 1.
1.
Okay.
Okay.
So the median is 1 plus 1 by 2.
Oh.
Okay.
Hmm.
And what is the meaning of mode here? What does mode actually mean? So mode means the most frequently occurring data value. So here most frequently means the value with the highest frequency, that is 5. So the what is the mode here? The mode is 0. Okay. Mode is not 5. Mode is the value corresponding to highest frequency. Okay.
Okay.
Value corresponding. The word corresponding is very important. Okay.
Okay.
The value corresponding to maximum frequency. Okay, so the value that
Okay.
corresponds to maximum frequency is 0, and therefore the mode is 0.
Oh.
All right, clear?
All right.
Okay. So I would like you to do this problem, number 2 you see here, except the standard deviation part. Okay.
Oh,
You
okay. Okay.
do the standard deviation, just find the mean, median, and mode, all three. Now this is the data in the list form, okay, not in the
Okay.
frequency distribution form. So how do you find mean, median, and mode?
Uh,
Okay, anyway, so I was asking about n. So n is 7, right?
all right.
And this is nothing but your sigma f in notation, okay? That is the
Okay.
total frequency. Now, can you tell me what is sigma x?
The X.
It is a sum of all observations, sum of all data values. So what do you get when you add 11, 12,
125.
125? That's right. Okay. And then what is the average? Then x bar
Average
is, yeah.
around 17.857.
So when you do 125 over 7, you get 17.857
7.
1428, etc. Okay, so in your
Yes.
exams, I would suggest you to first write the whole calculator display and then write the three significant figure value. What do you think is the three significant figure value here?
It should be just 17.8. Oh, yeah, 9. Yes.
Okay, so the
Yes.
answer for the x bar is 17.9 because this is your fourth significant digit, okay, fourth, and this is more
Okay.
than 5 or more. Okay, so
Okay.
you will give 1 to the previous value, carry 1. So 17.9 is the average, right?
Right.
Hmm. Now, was this too easy for you, or can we move on to something more challenging?
Yes.
Is this too easy? You know all this already?
Yeah, let's move to another one.
Okay, not a problem.
Okay.
So can you tell me what is standard deviation in this case?
The standard deviation is around 6.015.
6.01.
015.
Um, can you tell me what is sigma x squared?
It's near to 216.912.
No, I'm asking you what is sigma x squared? It cannot be in decimals. You are simply squaring and adding numbers. So it is 11 squared plus 12 squared plus 14 squared, right?
Let me have a look.
17 squared plus 21 squared plus 23 squared plus 27 squared. So this number cannot be in decimals.
Yes.
Yeah, I understand what you're telling me. Actually, we don't have to find this. Okay.
Okay.
Why do we not have to find this? What was wrong in what I was doing?
Just calculate the sum.
Yeah, no, what was wrong in what I have written? What is wrong in this? What is wrong in this?
Let me have a look. 11 squared plus 12 squared.
Okay, actually, it is not wrong. You know, you can solve it this way as well. What is the formula for standard deviation? Can you help me recall the formula?
Roots.
Square root of?
Probably brackets xi minus
Okay, so you're telling me
the frequency
sigma,
of
yeah,
sigma
xi minus x bar,
x
right,
bar and square
right,
over
times
n
f,
minus 1. Oh,
times f over
n
sigma
minus 1.
f.
Oh,
No, okay, so
sig
there are two things. Okay, there are two things here. We have something called we have something called S and there is something called sigma. Okay, so
okay.
this sigma is the standard deviation, whereas this S is the estimator. Estimator of standard deviation.
Oh,
Understood? So if you're asked to find standard deviation, you will find sigma with n, not divided by n minus 1.
oh,
Yeah. So you look at the given formula here. It's probably too small, but you observe this formula. What is the formula given to you? Sigma
I
x
just
minus
use,
x. You use your
yeah,
calculator?
yes.
Yeah. So you have to understand the difference between standard deviation and estimator of the standard deviation. Okay.
Okay.
So basically, we use the word, we use the symbol. Okay, let me tell you a little bit about uh, while studying statistics, you must have studied population and sample, right?
Right.
Population and sample. These are two things. And to understand certain properties or certain, you know, what is happening in the population, we study a sample of the population. Okay. So
Okay.
we collect data from the population to
Okay.
understand what is happening in the population.
Oh,
Okay, so these are the
okay.
symbols. So I'm going to write here mean, standard deviation. Okay, so population, for population, the symbol for mean is mu. Okay,
Okay.
and for standard deviation, the symbol for population is sigma. This is small sigma, small case sigma. This is, I mean, the word is same as, you know, what you use for this. This is also sigma, but this is capital sigma.
Oh,
This is capital sigma used for sum. Okay. And
okay.
this is small case sigma used for standard deviation. But for sample, mean is x bar and standard deviation is s. Okay.
Okay.
So in case of populations, we use n, and in case of sample, we use n minus 1.
Oh, I see.
Clear? Because we are trying to estimate what is happening in the population based on a small sample of the population.
Oh,
Okay, right?
okay.
So unless it is mentioned, unless they say the word estimator, you will not use n minus 1. You will always use sigma. There must be two symbols on your calculator. One must be sigma and the other must be s. Check carefully. Okay.
Okay.
So you would always give the value of sigma unless it is mentioned as an estimator. All
Oh,
right. So before this, so this is the formula sigma f xi minus x bar whole square upon sigma f. Okay.
mm.
Have you come across this formula before?
Yes.
Yes, right. Let us do see here. I have put it in the box here. Okay. Sigma x minus
Mm.
x bar whole squared upon n. Now there is another variation of that formula.
Oh,
What is the variation of that formula? If you simplify this a bit, you get more practical form. All right,
all right.
more practical form. So let me just write that here. More practical formula. If you want, we can see how this formula can be derived. Okay.
Okay.
So instead of s, I would like to write sigma here. Okay. Sigma is
Oh, is
okay. Let's look at what they have given. I am wondering now whether okay. Have you come across the word variance as well?
sorry.
Variance.
Gradient.
See here the word variance.
Oh,
Variance.
variance.
Variance. Have you come
Okay,
across
okay.
the word variance before?
No.
Okay. So variance is basically the square of standard deviation.
Oh,
Okay. So you see the formula for variance is without the square root. All right.
all right.
And then they have written standard deviation or S is square root of variance.
Okay.
Okay, so most of the time you will be asked to work with the standard deviation only. But let us just see what this variance means without, because it will help us do the calculations without the square root. Okay, so
Okay.
let me just write sigma or S. This formula is sigma xi minus x bar whole squared divided by n. Okay,
Okay.
right? So this is equal to sum of what is a minus b the whole squared? Xi squared
Square.
minus 2 xi x bar plus
Mm.
x bar squared. Okay,
Okay.
whole thing over n, and everything is in the square root. Okay,
Okay.
now we can open the brackets and we can give this sigma notation to each term. So this would be like sigma xi squared upon n minus sigma 2xi x bar upon n plus sigma x bar squared upon n.
Oh,
Is this bit clear?
yes.
See, please stop me and ask if you don't understand something. Okay.
Okay.
So I've just used a minus b the whole squared and I've opened the brackets. Okay.
Okay.
So this is like square root of sigma xi squared upon n minus, so here this I can write as 2x bar sigma xi upon n plus x bar squared times n upon n.
Oh,
Are you clear how I wrote this step and this step?
yes.
Are you sure?
Yeah.
So if you're clear, then it's fine. I'll move on. Otherwise, I would like to explain. You want me to proceed or explain this?
Just proceed.
Okay, thank you. So then this is equal to sigma xi squared over n minus this itself is x bar. Remember?
Yes.
And here n cancels to give you x bar. Okay, so on simplification, we get your formula. So on simplification, we get your formula sigma xi squared upon n minus, you see this is minus 2x bar squared, correct?
Yes.
Plus x bar squared. So we get minus x bar squared.
Square. Okay.
So this is the formula, which is a more practical formula
Oh,
for finding the standard deviation. Okay.
okay.
So that is why I was asking you to calculate what is sum of squares. So that is why I was asking you to find this. Okay.
Okay.
So can you now tell me what is sum of all squares? What was the original data? The original data is here 11, 12, 14, 17, 21, 23, 27. Okay.
Yes. Okay.
Yeah. So this is all about question 2. So if I put these values in the formula, what do I get? What is sigma xi whole square? Now, if you have the values,
The value. First one is 125. No. Yeah, I forgot the number. Sorry.
yeah. So I've highlighted something in green. Can you give me this value?
Sorry, I forgot the number of it. Probably 1,000, blah blah.
Here are the numbers. Eleven, 12, 14, 17, 21, 23, 27.
Oh yes. Hmm. So
So we are doing 121. 11 squared is 121. 12
Yeah,
squared.
so 12 square, 14 square, 17 square, 21 square, 23 square, 27 square, probably
Right.
equal to 15625.
No,
Oh, it's
check
too
again.
big.
Check again. No, it's too small.
Oh,
The number is actually 2449. Okay.
2.
Please check your calculations again. So this
Okay.
is 2449. And what is n? How many values are we looking at?
7.
7. And what is the average? Mean?
100. The mean.
We
1.
found the mean earlier, right?
17.9.
Correct.
Yes.
Now you observe here that for this calculation, I'm not using the rounded off value. Okay.
Oh,
I'm
okay.
using a more accurate value, which is 17.85714.
Oh,
Okay, so x bar squared. Now when you calculate this, what do you get?
let me have a look. 2,
You should get
4,
something like 5.56593. Okay,
Okay.
so we can
Okay.
say it is
Square.
5.57.
Yeah, 5.427 around I've got. Okay. Why it's different?
Yeah, because I think you are still taking n minus 1 in both. Here also you have taken n minus 1, and in finding you are using the estimator formula, S formula, okay? Whereas we are talking
Okay.
about sigma. All right.
Oh, I see. Yes.
So I've just substituted all the values in formula. Can you actually use a calculator to show this calculation? Root 2449 by 7 minus square of this.
Oh, now. Oh, I see. I just used 17.9 to calculate, so
Yeah,
it's a little
yeah.
bit small. Okay, I've done.
Done.
Yeah, done.
So I hope you're getting 5.5659. Yeah.
Yes.
Okay, let's look at the next problem. So basically, question 3 you see on the screen is asking you to find the same thing, mean, median, and mode. Okay, so we can skip that for now.
Okay.
Okay, we can skip for that for now. Can you work on question 4?
Question 4. Sure.
What is the answer to part A?
85.5.
No, the answer to part A. They're not asking you what is the mean. They're asking you find the value of sigma x.
Oh, so it should be 100. First question, A should be 113. Oh, 513.
513, right. So A part is sigma x. So that is 513. Okay. Next,
Okay.
one more data value is added to the set. The new mean is 84.9. So let us call x bar new. X bar new is 84.9. And what is this equal to now? This is 513 plus x over how much?
81.3.
No.
No, the B is not. Oh, still in A. 113 plus x over 7.
Over 7. Good. Okay. Because we are now adding this extra value, right?
Okay.
Yeah. So what do we get? The value of x as.
Well, I'll get 81.3.
That's right. Okay. Therefore, x
Okay.
is 81.3. So far we have done very good. Okay. So far we have done
Okay.
some easy problems. Let's look at slightly more complicated problem on mean and standard deviation. Okay. Can you read the problem?
Okay.
The mean of 10 boys. The mean of 10 boys' heights is 180 centimeters and the standard deviation is 10 centimeters. Okay.
Okay.
So a good idea is to write what is given to you in the notations. Okay. So they have done that. Mean is 180. Okay.
Okay.
Then the mean of 9 girls is 165 centimeters and the standard deviation is 8 centimeters. Question is find the mean and standard deviation of the whole group of 19 girls and boys. So this is a problem on combined mean and standard deviation.
Okay.
Okay, would you know how to work
Okay.
this out? So basically you have two groups. Okay, you have
Okay.
group A and group B. So mean of say number of elements in group A is NA and number of data values in group B is NB. Mean of group A is X bar A and mean of group B is X bar B. Okay.
Okay.
So what is the total number of data values? The total number of data values.
Number of data.
Sorry.
No. I just repeat what you say.
So total number of data values is NA plus NB. You understand this?
Yes.
And what is the sum of all data values?
Sum of all data value.
Sum of all data values is sigma XA plus
Plus
sigma
x sigma xb.
XB. But do we know what is sigma XA and sigma XB? Over here, we don't know what is sigma XA and sigma XB. But we can find sigma XA is
X
NA times
NA
X bar A.
times x bar A.
That's right. Good. And sigma XB is NB times X bar
Times B.
Yeah. So here,
Yes.
so combined mean is, so if I have to write combined mean, that is X bar A plus B
Oh.
is number of data values is A plus B, but the sum is now
Okay.
NA X bar A plus NB X bar B. right?
Okay.
Yeah. So that's what they have done here. You can see. So you were told that average of boys is 180. So that means, and how many boys were there? 10, correct?
Okay.
10 boys with average 180. So total 10 times 180, 1800. Okay, 9 girls with average 165. So 9 times 165, 1485. All right.
All right.
So the sum of the heights for the boys and girls is sigma x plus sigma y, which is 3285. And when you divide by the total number of observations, that is 10 plus 19, boys and girls together, you get 172.9 as the average of the combined group. Okay.
Okay.
Similarly, you need to find these values using the standard deviation given to you. So here, standard deviation of x is s squared x, standard deviation of y is x squared y, s squared y. Use these formulas and try and get this value. Okay.
Okay.
Francis, these notes will be with you. You go over this example and you can let me know if you don't understand something from this. We will take this up in the next lesson.
Okay.
All right.
All right.
And if you understand this, then please do attempt the next problem and you can share the answers with me. The next problem is here. This is one of the exam problems. You see, in a supermarket, two types of chocolate drops were compared. So you read that solved example first and then try to attempt this problem. And in the next lesson, we will start with the answers of this, or if you have any doubts. Okay.
Okay.
All right. So shall we call it a day?
Okay.
Bye. Have a good day.
Okay. Bye bye.